Hi guys, I'm Smita and welcome back to my channel where I talk about all things machine learning and AI related. Today is day 7 of 100 days of ML where we will be looking at the Pandas library in Python, which is a very essential library when it comes to machine learning. If you guys are new to this channel and you don't know what 100 days of ML is about, check out the video for day 0, which I will be leaving in the description box below, and that's going to do a great job at explaining to you guys exactly what 100 days of ML is all about. Without any further ado, let's get started with day 7. So we're going to be looking at a bunch of coding examples of how to use different functions in the Pandas library. And most importantly, we are going to be looking at how we can get a CSV file from Kaggle, from a dataset from Kaggle, and turn that into something called the Pandas data frame. And I'll talk more about that later on in this video. Before we get started, let's actually understand why the Pandas library is so important and what is it known for. So the Pandas library is known for something called the Pandas data frame, and that's why it's an extremely important library in machine learning. So what exactly is the Pandas data frame? The Pandas data frame is a two-dimensional tabular data structure. So it can be used to store data such as from a CSV file, from a JSON file, or from a database. So anything that you can think of to store tabular data, you can definitely use the Pandas data frame to do that. And the cool thing is, because it is stored in rows and columns, you can actually use the Pandas data frame and call data that you want, maybe from a particular row or a particular column. And you can do a bunch of different operations on it based on these rows and columns, etc. So this makes it very easy to work with, especially if you're trying to do data processing and pass this through machine learning models later on. One very important thing to note is that the Pandas data frame is a two-dimensional size mutable tabular data structure. So what does size mutable mean? Size mutable basically means that even after you have created it and initialized it, you can change its size. You can add more rows or add more columns, delete columns, etc. So this is very different from other Python data structures like a string or a byte data structure where it's size immutable. So you can't actually change it once you have created it and initialize it. Now the Pandas data frame has a lot of different attributes that you can call in order to find out things about a Pandas data frame that you have created. So for example, if by using the shape attribute, you can determine how many rows and columns this data frame has. By using the size attribute, you can determine how many number of elements the Pandas data frame has. So these are different things that you can do. If you use D types, you can determine what data types this data frame actually has. So does it have int, does it have string, etc. There's also a ton of different methods that you can call on a data frame that you guys create, and that also gives you a bunch of different information as well. So let's jump into the coding example and try out some of these functions. So the first thing that we're going to do is open up the Google's machine learning crash course website, where we will be looking at their Pandas ultra quick tutorial collab exercise. So click on this link and it should open a collab exercise, and let's get started. So guys, once it opens a collab exercise, it should look something like this. What you have to do is go ahead and actually create a copy. So save a copy in Drive. So that way we can actually edit and add our own code onto this. So once you actually click save a copy in Drive, it should be creating a copy, and you can click open in a new tab. Once you do that, you have saved this copy of Pandas collab into your Drive, and you can actually run this and also add different codes to it and save it as you go along. So the first thing we're going to be doing is actually importing the Pandas library. So import pandas as PD, and we're also importing the NumPy library because later on what we're going to do is first create a NumPy array and then change that into a Pandas data frame. So you can go ahead and run that code. So the first thing that we're doing is actually creating a data frame by first creating a NumPy array and then putting that into a data frame. So let's see how we can go about doing that. So the following code cells creates a simple data frame containing 10 cells organized in the following way: 5 rows by 2 columns. So the first thing they have done is actually created a variable called myData, and by using np.array, they're creating an array a 5x2 array, as you guys can see, and they are filling that into the my data variable. Next up, they're creating a NumPy array called my column names, which includes the names of the columns that we want, which is temperature and activity. And then we are creating my data frame, which we're using a pd.dataframe in order to create a data frame, and in that we have to list two parameters, the data and the columns. So data is equals to my data, and then columns is equals to my column names. Once we do that, we're gonna print my data frame to see that everything is working as it should. So as you guys can see, once you run this cell, you print out your data frame and it should look something like this. So this 5x2 array that you have created here is shown here, and the column names are shown here. So put that all together and you have your Pandas data frame. Now, what about adding a new column into your existing data frame? So let's see how we can go about doing that. To add a new column into our data frame, all you have to do is actually put my data frame, and then in square brackets, you put the name of the new column that you want to add, equals to my data frame activity, which is this column right here, plus 2. So what you're actually doing is you're creating a new column called adjusted, and you're saying, okay, take all of the values of activity and add that by 2, and then put that into the new column called adjusted. We can also print our data frame again to see the new column. So as you guys can see, we've created a new column called adjusted right here, and it is essentially all the values in activity plus 2. Next up, we're going to see how we can get subsets out of our data frame. So for example, if we only want a particular row or a particular column, how do we actually get that? The first thing that we're going to do is we want rows from 0 to 2. So 0, 1, and 2. So how we can do that is say my data frame dot head and then put in the value 3. So what it does is it prints out all of the rows up till the value 3. And let's say we only want row number 2. In order to do that, we have to call the iLock method and give it the input of 2 because we only want row number 2. And if we want rows 1, 2, and 3, what we do is we say my data frame 1, colon, and then 4. So as you guys can see, this is actually different from when we want rows 0, 1, and 2. When we want rows from 0, 1, and 2, we didn't use this method. We just said, we just call the head method. The reason why we call the head method is because if you're calling the head method, it's taking the row from 0, so from the head. And let's say if we only want a particular column, so we only want data from the temperature column. So what we can do is say my data frame, and then in square brackets, we would just write the name of the column that we want and we can print it. So let's print this and test all of them out. So in the first one, we wanted from rows 0, 1, and 2, and that's what we got. In the second example, we wanted only row number 2, as you guys can see. In the third one, we wanted rows 1, 2, and 3, and that's what we had. And in the last example, we wanted only the column with the temperature values. So only column with the name temperature, and that's also what we got. So next up, let's actually test what we have learned from this video and also with our previous video of NumPy. Let's test our knowledge and attempt this task of creating a data frame. So what we have to do is create a 3x4 Pandas data frame in which the columns are named Eleanor, Chidi, Tahani, and Jason. Populate each of the 12 cells in the data frame with a random integer between 0 and 100, inclusive. So it has to include 100 as well. So the first thing we're going to do is create a Python list to hold the names of our columns, similar to what we did right here, where we held my column names and temperature and activity as the column names. We're going to do that for this. So column names is equals to square brackets and Eleanor, GD, and you can actually just go ahead and copy this. So that's how you create a Python list with your column names. And now let's actually go ahead and create a 3x4 NumPy array with random integers from 0 to 100. If you guys remember how we did it in the last video, how we created random integers, so let's see. So let's create a NumPy array called row data equals to np.random.randint, because we want to generate random integers. And if you guys remember the parameters, as you can see, the first parameter is the low, which is the minimum value, and then high is in the maximum value, and then the size. So low equals to 0, high equals to 101. Why 101? Because we want to generate random integers between 0 and 100 inclusive. So since we want to include 100, we should put our high value as 101. And our size would be 3, 4, because we want to generate a 3x4 matrix. Now let's actually put our row data and column names into a Pandas data frame. If you see how we did it before, my data frame is equals to pd.dataframe and then data and columns. So let's do that. New df is equals to pd.dataframe. Data is equals to row data, and columns is equals to column names. And once we have done that, we want to print the entire data frame. So print new df. And we also want to output the value in the cell of row 1 of the Eleanor column. So how do we actually call that? So let's print new df. And the first thing we know is that we have to write the column name that we want to get. So since we want to get a value out of the Eleanor column, so let's write Eleanor. And since we want the value in row number 1, so it's 1. And that should output the value in the cell of row number 1 of the Eleanor column. The third thing that we want to do is create a 5th column named Janet, which is populated with the row by row sums of Tahani and Jason. So what we can do is new df, and simply, since you want to create a 5th column named Janet, simply write Janet in our square brackets equals to new df Tahani. So we want the values of the Tahani columns added with the values of Jason column. So Jason, and that would give us a 5th column named Janet. So we'll print out our data frame again to find out if that has been done. So let's go ahead and run this and get our output. So when we run this first data frame that we're seeing right here is our first data frame that we have created. So this is how NewDF initially looks like after we have filled it in with random integers and also our column names, Eleanor, Chidi, Tahani, and Jason. And as you guys can see, we've generated random integers between 0 and 100, including 100. So that's done. And this next line here, 59. So 59 is actually the first row of the Eleanor column, which is exactly what we wanted. We were printing that out. So that's done. And the second data frame is in which we added a new column called Janet, right? And Janet, the Janet column is a sum of the values in all the in the Tahani column and adjacent column, and that's also true. So 31 plus 66 is 97, etc., etc. So this is a very simple way of how we can create data frames, specify our own column names if we wanted to, generate random values for the data frames, fill that in, and also create a data frame and do various operations on your data frame, for example, adding a brand new column, etc. You guys can actually go ahead and check your code by clicking here. It's pretty much almost the same, except obviously they use different variables, but the gist of it is definitely the same. Next, let's look at copying a data frame. So copying a data frame is pretty important in Pandas. Pandas provides two different ways to duplicate a data frame. Referencing. If you want to assign a data frame to a new variable, any change that you make to the data frame or to the new variable will be reflected in the other one. So that means the new data frame that you have created, that you have duplicated, is actually still linked to the old data frame. So whatever changes you make to the new data frame, it's still going to be changed in the old data frame as well. So that's one way. If you would like it, that's a way of doing that. That's called referencing. Copying is another way. So in copying, we would call pd.dataframe.copy. That's a method we would use to create a truly independent copy. So changes to the original data frame or to the copy, they're not actually reflected in each other. So they're not linked anymore. So any changes that you make to the original data frame or to the copy, they're not linked, and it's not actually going to carry through in the other data frame. This difference is actually very important when you're dealing with data frames. And if you want to create copies of data, perhaps you want to create some operations on a particular data frame, but you don't want it to affect your original data frame. This is one way of doing that. So if you simply want to create a reference, all you have to do is just create an empty variable and say that it actually equals to your data frame. That's a way of just creating a reference. So any changes that you make, the same changes will actually be applied to your reference as well. But however, if you want to create a copy of your data frame, you have to use the .copy method. And in this situation, you'll be creating a truly independent copy in which any changes you make will only stay within that variable, that data frame. Next up, let's actually experiment with a brand new data set that we're going to get off Kaggle, and we're going to actually convert that into a data frame. So create a brand new Colab file if you would like, and let's proceed. So as usual, the first thing that we're going to do is import pandas. So import pandas as PD, and the data file and the data set that we're actually going to be looking at, and this is the data set that we're going to be looking at. It is a data set of data science and STEM salaries. It has over 62,000 salaries from top companies, from top tech companies, and it's actually scraped off levels.fyi. So it's a pretty extensive data set with 29 different columns of different types of data, like company, the level that the employee was at the company, their title, their total yearly compensation, their location, years of experience, years at the company, etc. And what we're going to do is we're going to take this file, this CSV file from Kaggle, and then convert that into a data frame using Pandas. I've added a link to this Kaggle set in the description box below, so definitely check that out. And once we've opened it, you can go ahead and actually download this. And once you've downloaded it, we're going to import that file into our Colab file. So let's go. So we're going to create a data frame called df. df is equals to pd.read.csv, pd.read_csv. So read CSV is a method which reads CSVs from either file or even from a link. So the first thing that you guys have to do is actually upload the file that we downloaded onto Google Colab. An important thing that you should note is with Google Colab, the files that you actually upload is temporary. So if you refresh it and you start your runtime all over again, you will lose that file. So what you can do is actually mount your Google Drive onto Google Colab, and it will permanently be there. But that's a pretty long process. So what we're gonna do is just, you can click this in order to upload your file, and once you've uploaded, it should come here. And once you see your file, you're gonna click this 3 dots and click copy path, and you're gonna paste this here. With some apostrophes. So we're gonna read the CSV file, and we're actually converting that into a data frame. After that, let's actually go ahead and print our data frame. So we have converted our CSV file. We have gotten our CSV file and we've converted that into a data frame. As you can see, there's a bunch of different columns, and there's a lot of columns. We saw that there were actually 29 different columns. Let's actually go ahead and look at the names of each of the columns. So print df.columns, and we're going to run that. So these are all the names of the different columns in this data set. Now we want to actually go ahead and do some linear regression on this. And if you guys remember, with our earlier linear regression problem, it was to do with salary, and it was based on comparing the numbers of years of experience and the salary. So we're going to do something similar. We have 29 different columns. We don't need all of them. So let's actually focus on which columns that we would like. So what we're going to do is we're going to create a new data frame called salary df, and we're going to get only the columns that we want from our original data frame and put that into salary df. So from our original data frame, we would want the total, we want the company, and we want the total yearly compensation. Just copy and paste that. We want years of experience. Years at company, we want years at company as well. We want base salary as well. And I think that's about it. That's a pretty good range of different features that we can look at in order to do linear regression. So let's run that. And let's actually go ahead and print salary df dot head, just to see maybe the first 5 rows and see how our data frame looks like now. So we have company, total yearly compensation, years of experience, years at company, base salary. So I think these are pretty good indications, and we can use these features to actually do linear regression in order to maybe create a linear regression model that will help to predict total yearly compensation based on years of experience, years at company, and then base salary. So guys, that's what we're going to be doing in the next video. So definitely be sure to check that out. I hope this video was helpful in explaining to you guys Pandas, and how Pandas is such a useful tool when we're dealing with data and we're dealing with different data sets such as CSV files, JSON files, etc. You can do a lot with the Pandas library. In fact, most likely if you're dealing with any sort of tabular data, you'll definitely be using the Pandas library. Definitely go ahead and also practice on your own and look at other examples as well. You can also look at the official Pandas library website, and you can look at the different methods and try that out for yourself as well. So hope this video was helpful for you guys. Let me know what you guys thought in the comment section below, and see you guys in my next video.